Hello friends, I hope you all are doing great. Welcome to our YouTube channel The Engineering Projects. In today's tutorial, we will have a detailed overview of Arduino Mega 2560. We will first discuss the related theory, and later we'll simulate it in Proteus software. So, let's get started. I have divided this tutorial into 4 parts. In the first part, we will discuss the basic introduction of Arduino Mega 2560, like what is Arduino Mega, why we need to use it, why is it so famous, etc. In the second part, we will discuss its hardware architecture, where we will have a look at its pinout, and the different functions associated with these pins like communication protocols, PWM, etc. In the third part, I will show you how to add its library to Proteus software for designing its simulation. And finally, in the last section, we will design a small simulation in Proteus software. In the last video, Introduction to Arduino Uno, I have interfaced the Uno board with LCD. So today, we are going to move one step forward, and will interface both LCD and keypad with a Mega board. We will design a code that will display the pressed key on the LCD screen. I have also shared a complete tutorial on my blog, and its link is given in the description of this YouTube video. Now, first let's have a look at what is Arduino Mega 2560. Arduino Mega is a microcontroller board, designed by Arduino.cc. The microcontroller used in this Arduino board is at Mega 2560. It comes with more memory space and input-output pins, as compared to other Arduino boards. Arduino Mega has 54 digital pins, starting from 0 to 53. These digital pins are used to interface digital sensors and modules with Arduino Mega. Moreover, it has 16 analog pins starting from A0 to A15. These pins are used to interface analog sensors. We need to specify it in the programming, whether we want to use these pins as input or output. If we are interfacing any sensor, then we need to make these pins input, so that we could read the sensor's data, but if we want to control any module or motor, then we have to make these pins output, so that we could send instructions. For example, we also have 15 PWM pins in Arduino Mega, which are used to generate PWM signals. Pin number 2 to 13 are all PWM pins, and pin number 44, 45 and 46 are also PWM pins. If you want to control the speed of a DC motor, then you need to use any of these PWM pins. It also has 7 ground pins in total, distributed over the board. I have encircled them. It also has these 3 power pins, V and will provide the input voltage. Then we have 5 volts pin and 3.3 volts pin. It also has 1 reset pin, which is used for resetting the board programmatically. Making this pin low will reset the board. There's also a reset button present on the Mega board. Moreover, it also has an ICSP header for connecting third-party modules. Arduino Mega comes with a crystal oscillator of 16 MHz. In order to power up Arduino Mega, we have 2 main power connectors. One is USB port and the second one is DC power jack. We can plug a 12 volts adapter or a battery with this power jack, and Mega will turn on. Moreover, if we connect Arduino Mega with laptop via USB port, that will also turn it on. USB port is also used to upload code in the Mega board. Arduino IDE is the official software used for designing and uploading code. Moreover, it also has 4 LEDs embedded on it. The first one is power LED, it will turn on as the Mega will be powered up. Second LED is connected to pin number 13 and is used for testing purposes. When you buy a new Arduino Mega, then first upload the blink code to check this LED. If it's blinking, your board's fine, if not, you need to buy a new one. Third and fourth LEDs are connected to TX and RX pins, and they start blinking if we perform any serial communication, which we are going to discuss next. Arduino Mega supports 3 types of communication protocols, named Serial Protocol, SPI Protocol and I2C Protocol. These communication protocols are used for data transferring between Mega and third-party modules. For example, GSM module SIM900 works on Serial Protocol, while RTC module DS1307 works on I2C Protocol. So we need to connect these modules with respective pins of Arduino Mega. Arduino Mega has 4 hardware serial ports, which means we can connect 4 serial modules with Arduino Mega. If you want to connect more than 4, you need to use software serial library. Pins of the first serial port are pin number 0 and 1, where pin number 0 is RX, used to receive data, while pin number 1 is TX, used to transmit serial data. The USB port is internally connected with these hardware serial pins, so if you have connected any serial module at these pins, you won't be able to upload code in Arduino Mega. So, it's better to use other serial ports available. Second serial port is available at pins 18 and 19, where 18 is TX and 19 is RX. Next we have a serial port at pins 16 and 17, where pin number 16 is TX and pin number 17 is RX. And the last serial port is at pin 14 and 15, where pin number 14 is TX and pin number 15 is RX. Arduino Mega 2560 also has one SPI port, which we can operate through these 4 pins, pin number 50, 51, 52 and 53, where pin number 50 is MISO, short for master in slave out, pin number 51 is MOSI, short for master out slave in, pin number 52 is SCK, short for serial clock, and pin number 53 is SS, short for slave select. So, using these 4 digital pins we can perform SPI protocol in Arduino Mega 2560. The third protocol is I2C protocol. Pins used for I2C protocol are 20 and 21. Here, 20 is SDA, short for data line, and 21 is SCL, short for clock line. Again, we have to define it in the programming, how we want to use these pins. Now, let's have a look at the built-in memories present in Arduino Mega. Arduino Mega comes with 3 types of built-in memories, named flash memory, also called ROM, SRAM memory, also called RAM, and EEPROM memory. Arduino Mega 2560 has a flash memory of 256 kilobytes. It's a non-volatile memory, meaning the data in ROM memory will remain intact, even if we remove the power supply of the Mega board. As it's a non-volatile memory, that's why it's used for storing the programming code or any permanent settings. Bootloader is a software code that is pre-installed in every Arduino board. It's installed in the flash memory of Arduino Mega and takes around 8 kilobytes space, so from 256 kilobytes flash memory, 8 kilobytes memory is already occupied by the bootloader. Second one is SRAM memory, it's short for static random access memory, and usually called RAM memory. Arduino Mega has a RAM memory of 8 kilobytes. It's a volatile memory, so if we reset or restart the Mega board, RAM memory will get erased. This memory is used to store temporary data like variables. Third type is EEPROM memory. Arduino Mega has an EEPROM memory of 4 kilobytes. It's a semi-volatile memory and thus can be erased by programming but remains intact if power is lost. So far, we have studied theoretical knowledge about Arduino Mega. Now let's practically work on this powerful board. I am not going to work on a real Arduino Mega board, instead I am going to design its simulation in Proteus software. If you want to learn the Arduino programming language, then I would recommend you to design simulations in Proteus. Working on real hardware is quite difficult, as you have to purchase the components and it also involves electronics. In Proteus simulation, you just have to design your circuit once, and then you can completely focus on your programming side. When I work on Arduino projects, I normally design my programming algorithms in Proteus, as testing with real hardware is too time-consuming. Proteus doesn't have Arduino boards in its components library, but we have designed its library, which you need to install in your Proteus software, and you will be able to simulate Arduino boards in it. We have designed 2 libraries of Proteus containing Arduino Mega board. I have given both of these links in the description of this YouTube video. This library is titled as Arduino Mega 2560 Library for Proteus version 2.0. If you install this library, it will only add Arduino Mega board in your Proteus software. In order to download it, click on this download button and it will open this download page, where we need to wait for 20 seconds. And here's the link generated. Let's click on this button to download zip file, and here we got our zip file for Arduino Mega 2560 Proteus library. I am going to click on cancel, as we will install this second library. This library is titled Arduino Library for Proteus version 2.0, and by installing this library you will get these 6 basic Arduino boards. So, let's install this second one, and again we need to click on the download button. Here's the download page and again we need to wait for 20 seconds. Let's click on this button to download the zip file of Proteus library. Here, we got our zip file. Let's click on Open With. Open this folder, and here we have this folder named Proteus Library Files. This zip file also has a simulation ready to simulate, but we will design a new simulation from scratch in a minute. First, we need to add these 2 files in the library folder of our Proteus software. So extract these files and now click on C drive, Program Files. Here we have Lab Center Electronics, and then Proteus 7 Professional. Click on Library folder and now click OK. As I already have these files in my library folder, so I am going to click on Yes to all. That's it. We have successfully placed these two files in the library folder of our Proteus software. Now let's open our Proteus software. And in the Components section make a search for Arduino Mega. Here select Arduino Mega 2560V 2.0 and click OK. Let's place Arduino Mega in the workspace. So, now we are ready to design its simulation. In the first tutorial, I have interfaced an LED with Arduino Nano, and then we have seen the interfacing of LCD with Arduino Uno. So today we will work on the keypad. We will interface both LCD and keypad with Arduino Mega. We will press buttons on the keypad and will display the pressed characters on 20x4 LCD. So, let's search for a few more components. First I am going to search for LCD library. And here we need to select LCD 20x4. Next, make a search for keypad. I am going to select this small calculator keypad. It's a 4x4 keypad, means it has 4 rows and 4 columns. And we also need to search for pot-HG, it's a variable resistor. Select it too. Now, let's click the OK button to close this dialog box. Let's first place LCD in the workspace. Next we need to connect terminals, so clicking on Terminals mode, and here we need to select Default. I am going to quickly place these terminals, as we have already discussed this circuit in the previous video. Let's add their labels. Next, we need to connect these terminals with the Arduino board. Giving them the same labels as that of LCD pins. Now let's open the Arduino IDE. And click on File, and then Examples. And here we have Liquid Crystal Library, and I am going to open Hello World example. Let's compile the code to get our hex file. Here's our hex file, so I'm going to copy it. Arduino IDE creates this hex file in the temporary folder of the laptop. Now in the Proteus simulation, double-click on Arduino Mega to open its Properties panel. And in the Program File section, paste the link of the hex file, and click OK. Now, let's run our simulation. LCD is not working properly. Oh, I forgot to connect a variable resistor. Let's stop the simulation. Let's connect this variable resistor with the LCD. It controls the brightness of LCD. Let's run our simulation again, and it's still not working. Oh, why am I making such silly mistakes? We need to connect a ground with the read-write pin, as we are writing on this LCD. Let's test it one more time. And yeah, now it's working fine. We have a Hello World message, displayed on LCD. Let's stop the simulation to add the keypad. We need to make some space for the keypad. Here, I am going to place this 4x4 keypad. Again, we need to connect default terminals with its pins. We need to label these pins, and as I did for LCD, I am going to use the name of keypad pins. We also need to connect these terminals with the Mega board. So, I am interfacing the keypad with pin number 14 to 21 of the Mega board. Let's assign them the same labels as that of the keypad. Now, let's open the keypad example. So, File, Examples, Keypad, and click on Hello Keypad. This example prints pressed keypad characters on the serial monitor. Let's copy code from it and add it to our LCD code. First, I am going to copy the library and pasting it here. Let's remove these comments to clean our code. Now, let's copy this keypad initialization code and paste it here. We need to make few changes in the code to make it compatible with our circuit. As we are using a 4x4 keypad, so we need to change the value of columns from 3 to 4. Next, we need to change the characters of this array and make it look like our keypad in Proteus. We also need to add the fourth column in each row. Next, we need to change the pinout. Keypad rows are attached to pin number 14, 15, 16, and 17. While keypad columns are attached to pin number 18, 19, 20, and 21. We also need to copy-paste this keypad map function. Let's remove these comments. Here's the code which will detect the pressed key of the keypad, and will print it on the serial monitor. Let's copy this code and paste it here. As we want to print the keys on LCD, so let's change this code. It's lcd.print. Now, we need to compile the code. And let's run the simulation. It's working fine. And you can see, as I press the keypad button, its character got printed on the LCD. But these characters are printing on the same LCD location. Let's stop the simulation. Here, we need to move this set cursor code from loop to setup function. Let's compile the code again. We need to run the simulation. And now you can see, keypad characters are printing correctly on LCD. So, that was all for today. I hope you have enjoyed today's tutorial. I have given all the mentioned links in the description of this YouTube video. If you have any questions, please ask in the comments. Take care. Bye.